Okay, students. So we'll move on to the question number 3. That is, draw a DFA to accept strings of A's and B's having exactly one A. Okay. So in previous two questions, we discussed like at least one A was the condition. But here, the question states that the string must have, okay, exactly one A. Okay. Then the possible, the input strings, whatever we need to discuss over here will be single A, okay, at exactly one A it is, okay. Then BAB, it is possible, or else ABB, that is also possible, okay, or else uh, double B A, okay, it is possible. But if you are having like double A, it should be rejected, remember this, okay. So these are the possibilities of accepting, okay, and this is the possibilities of rejection, okay. Remember, double A if you have, then it should be rejected, okay. Single A, it should be available, okay. It may be like starting with any number of B's, or it may be ending with any number of B's, does not matter, okay. But your DFA must have like only one A, okay. If it is there, then it should be accepted, okay. If this is the case, then obviously the length of this particular minimum string is 1 plus 1 2 states we will be getting, okay. Is it right? Q0 is the start state, then later Q1 will be the final state, okay. If I make it as final state, then whenever we get a single A, then it will be accepted. Make it as start. Okay, fine. Is it right? Okay, if you get single A, it will be accepted. Then what about this BAB? Okay, see, if you are getting B, fine, then you will be remaining in Q0 itself. Is it right? Because we don't know. Okay, further, whatever we are having, okay, like if you are having like series of B, okay, like BBB, triple BA, okay, when we encounter a single A, then only we need to go towards final state, okay, because that is what the condition, minimum requirement, okay. Until we find that minimum requirement, you will be remaining in the start state itself, okay. When you find that, okay, the expected requirement, okay, so you are moving towards the final state over here, okay. So how many number of B it may be begin with, okay, you will be remaining in Q0 itself, okay. Then if you are having a string like BBB, okay, it should be rejected, right? Because it is not consisting of A, single A. One A is not also consisted by this particular example, okay. Then it should be rejected. How it will be rejected? It will be in Q0 itself, okay. It won't go towards the Q1, okay, because it does not consist of single A, right? Okay, so it will be in Q0 itself. So we need to provide a self loop for Q0 when it receive B exactly. So Q0, like we are having two different alphabets in this question, A and B, okay. So A over B over. Then later we'll come back to the Q1, okay. See here, we may be having examples like, okay, so this example let me consider, okay. So when we receive B, you'll be in Q0. Later what we have, A we are having, we are coming to the Q1, okay. Then later if you are having B, observe it carefully whether this should be accepted or rejected. It should be accepted, okay. But after processing the B, your DFA must be in final state. So what we need to do, we need to provide it for a self loop, okay. Self loop for B. Then if string begins with any number of B's followed by one A and followed by any number of B's, it will be remaining in final state, okay. So this one will be accepted by this DFA, second one also, third one also. Observe it carefully, okay. Q0 on receiving A, it will come for Q1, right? Okay, later what we have, double B we are having, first B and second B, it will be remaining in Q1 itself. Then later, what about this? Observe it carefully. Double B we are having, you'll be in Q0 itself. When you receive A, you're coming for Q1. Okay, finally it will be accepted. But double A, no, it should be rejected. Remember this. Double A if you are having Q0, you will be coming for Q1. Okay, Q0 to Q1 on receiving first A. What about second A? We are not specifying any transition for A. Remember, if you write comma A, then it will be totally wrong. We are violating this condition because, observe it carefully, if the question is like this, double A, okay, first A, it will come for Q1, okay, second A, it will be there in Q1 itself. Then double A will be accepted by this machine. Is it right? Okay, that should not happen, remember, okay. So this is what a DFA, what we can design for this particular condition, okay. So DFA may begin, or else the string may begin with any number of B's, or it may end with any number of B's, does not matter. But some way it should consist of one A, okay. This is how we are processing. Okay, so this is one possibilities of designing a DFA for this particular question. But just observe, okay, so for Q1 we are not specifying a transition for A, is it right? Okay, usually Usually for each state, okay, we must have at least one transition for each and every alphabet. Remember, okay, for Q0, yes, for B we have, for A also we are having. But for Q1, there is no transition for B. Okay, if you want, you can leave as it is. Okay, no need to make any changes. But if you want to provide a transition for A, okay, from Q1, but it should not be accepted, means what we can do, we can just provide one more state. Okay, we are calling it as a trap state. We are calling it as a trap state. Okay, why we are calling it as a trap state? Okay, see, once the DFA enter into this particular state, okay, there is no way to reach the final state. I repeat, when DFA enter this trap state, there is no way to reach the final state. Okay, so if I label this as A, okay, then whenever we find more than one A, you are coming for Q2. And for this, I'm going to provide a self loop like A or B, A comma B I'm providing. Okay. Then observe it carefully. If you are having a string pattern like double A, BB, okay, double A, BB, observe it carefully. Double A will be like Q0 to Q1, Q1 to Q2. Okay. BB will be Q2 itself. Okay. We are not going back to the final state at any cost. We don't have any possible transition going back to the final state. So this we are calling it as trap state. Okay, if you want to provide like all the transition for the state, okay, then you can do like this. Otherwise, you can skip this particular portion. Okay, if you want, you can provide the trap state over here. Clear? Okay. So in my transition diagram or else in transition table, I'm going to skip that trap state. Okay, fine. So now, how we can write the machine for this? Okay, machine M will be equal to, okay, sorry, machine M will be equal to, so Q, comma, sigma, comma, delta, comma, Q0, comma, F. Is it? Yes. Okay. So here, as usual, Q will be equal to Q0, comma, Q1. Is it? Then delta will be equal to A, comma, B. Don't get confused. Okay, minimum requirement is A. Okay, but alphabets are A, comma, B. Okay, remember this. A, comma, B. Then later sigma over. Then Q0 is the start state. Okay, is Q0 is the start state. Then F is equal to what? F is equal to final state, that is Q1. Right? Then later delta of Q0 on receiving A, it will be going for Q1. Is it? Okay. Then delta of Q0 on receiving B, it will be going towards Q0 itself. Is it right? Q0 on receiving B, it will be in Q0 itself. Then delta of Q1, comma B will be equal to Q1 exactly. Okay. So this is what the complete definition of DFA. Okay. So now, if you want to draw the transition table for this, okay. So please try for drawing the transition table, all of you. Okay. So here we got two inputs, alphabet. Okay. So two columns it will be. So here. So delta of, so here A and B it will be. Then here Q0 and Q1. So Q1 is the start state. So star it will be, and here Q0. Q0 on receiving A, just observe the skeleton. Don't refer the transition function. Okay, refer the skeleton itself. Q0 on receiving A, it will be going for Q1. Q1 on receiving B, it will be remaining in Q0 itself. Q1 on receiving A, see here, observe it carefully. Q1 on receiving A, do we have any transition? No. Okay, so just provide a dash. Okay, that states that we don't have a transition for Q1 on receiving A. Then later Q1 on receiving B, it will be remaining in Q1 itself. Okay, students. So this is what the complete discussion about the problem number 3. Okay, so in the next video, we'll solve the problem number 4.